Alright, in this question, we are looking for the sum of this given series here. Alright, so what is the series here? It's NC1 plus 2 into 5 into NC2 plus 3 into 5 square into NC3 and so on up till n terms. I will call this sum S. Alright, so I have this much. Now, what I'll do is, I'll write this in sigma form next. So, this S is nothing but sigma R equal to 1 to n. Why am I writing R equal to 1 to n? I see this NC1, NC2, second term, NC3, third term. We're going up till n term. So we go up till NCN. Alright. So R equal to 1 to n into NCR into. What is the next part? There's a 1, there's a 2, there's a 3, there's a 4, there's a 5 and so on. So that is nothing but R itself. Alright. So R into NCR into. What is the next part? 5 raised to something. Alright. 5 raised to what? 5 raised to 0 is what is multiplied with the first term. 5 raised to 1 is multiplied with the second term and so on. So you get 5 raised to R minus 1 here. Alright. So this is what I get as my sum. Now this R into NCR, that R part is causing a problem. If it was just NCR into 5 power R minus 1, I can just expand it as a binomial expansion and then solve it. But then there's an R in between. I need to get rid of it. That is the one creating the issue here. Alright. So to get rid of R into NCR, what do? I'll write that as R into NCR equal to N into N minus 1 C R minus 1. Alright. So this is what I have here and that's what I'll substitute. Then I get R equal to 1 to N. What is NCR into R? That's what I found right now. N into N minus 1 CR minus 1 into 5 power R minus 1. N is a constant, so I can take it outside the sigma. Alright. So I took N outside the sigma and this is what I get. Alright. So N minus 1 C R minus 1 into 5 power R minus 1. R is going from 1 to N. Let's imagine we are expanding this here right now. Okay. So when we expand this, what do we get? This part. When I put R equal to 1, this becomes N minus 1 C0 5 power 0. What's the next term? R equal to 2. So you get N minus 1 C1 5 power 1 all the way up till R equal to N. Okay. This is N minus 1 Cn minus 1 5 power N minus 1. Does this expansion look familiar to you? Does this look familiar to you? It should. Alright. So, or what we can do is see that R is equal to 1 here. Alright. So, S will be R minus 1. Okay. Let's define an S and call it R minus 1. Alright. So, this becomes N into R equal to 1 to N. So, when R is equal to 1, what will the value of S be? S will be equal to 0. And then when R is equal to N, what is the value of S? It becomes N minus 1 into what? N minus 1. Instead of R minus 1, I'll put S into 5 power S. Alright. This should at least look familiar to you. Alright. When we open that, we got the same thing. N minus 1 C0 5 raised to 0 plus N minus 1 C1 5 raised to 1 and so on so forth. Alright, that sum comes up to nothing but 1 plus 5 raised to N minus 1. In the sense that if I have NCR into X power R, okay, if you're taking the sum of all those terms, you're getting nothing but 1 plus X raised to N. Okay, so that's the idea here. NCS into A power S. A is 5 here. Okay, this, if you sum it from R equal to 0 to the last term, R equal to N, you get 1 plus A raised to N. So this becomes nothing but N into 1 plus 5 raised to, it's not N on top, it's N minus 1 here. Okay, don't forget that. So it goes till N minus 1. So this I write as N into 6 power N minus 1 and that will be my final answer. Alright, so N into 6 power N minus 1 is nothing but option A and that will be the correct answer here. Got that? Alright, take a look at this question. If CR represents 100 CR, then find 5 into C0 plus 8 into C1 plus 11 into C2 all the way up till 101 terms. So let's call this summation, all right, this series, sum of this series as S, okay, up till 101 terms. Now, let's write this in sigma notation. Okay, to write that in sigma notation, what we do is I'll put R equal to 0 to 100. Okay, so R equal to 0 to 100 NCR into, so R equal to 0 term will be 5, R equal to 1 term will be 8. So I'll write that as 3R plus 5. So I get sigma R equal to 0 to 100, 3R plus 5 into CR. All right. So CR here is nothing but 100 CR. Okay. So I'll just make that change to everything. It becomes 100 CR. Now, how do we calculate this? I'll split this into two parts here. What are the two parts? 3 into sigma R equal to 0 to 100 CR into R. 100 CR into R. Alright. So it was 3R into 100 CR. 3 is a constant. I simply took it outside. Next, plus 5, which is a constant. I take it outside the sigma. R equal to 0 to 100. 100 CR. Okay. Now, here R into NCR is there. How do we get rid of R in the numerator there? I write R into NCR as nothing but N into N minus 1 CR minus 1. Alright, so then this becomes 3 into sigma R equal to 0 to 100. R becomes N here. N is 100. So if I take 100 outside, the 3 outside becomes 300 into N minus 1 CR minus 1, which becomes 100 minus 1, which is 99 CR minus 1. All right. But the problem here is if I put R equal to 0, the first term here, it will become 99C minus 1, which is not permissible. So I take from the next term R equal to 1. All right. From here, is it permissible? Yes. You start from 99C 0. That's the idea here. Plus 5 into what? The summation R equal to 0 to 100, 100 CR. Okay. So if you have NCR, you're summing from R equal to 0 to N. What will you get? You will get nothing but 2 power N. Don't forget this. Alright. So let's use that here. This becomes 2 power 100. Okay. So then, what does this become? This can be written as 300 into, when I expand this, what will I get? 99C0 plus 99C1 all the way up till 99C99. Okay, just like we found that this 100C0 plus 100C1 all the way up till 100C100, that sum is 2 power 100. Similarly, this 300 is multiplied by this sum, which comes out to 2 power 99. Alright, plus 5 into 2 power 100. I'll write that as 10 into 2 power 99, so that I can take 2 power 99 common. So when I add both of them up, I get 310 into 2 power 99. Got that? All right. Okay. So now let's try another method to solve this same problem. I have S here. Now this was my S. I found out that my term here, okay, would be 3R plus 5, my general term, 3R plus 5 into NCR. Okay, that is what this is. So when I look at the 101th term, I put R equal to 100 into this. That's how I get the 101th term here. Okay. Now what do? We take the series and write it in the reverse order. That's all. I'm writing the same series again, just that it's in reverse order. Okay. Now, you know that 100C0 can be written as 100C100. Okay. 100C99 can be written as 100C1. 5C0, sorry, 5 into C0 can be written as 5 into what? 5 into C100. 100C100. Alright. So, what does this become? This sum is what I'm adding. 100C0 into 305 plus 100C0 into 5. Alright. Becomes 100C0 into 310. Okay, 305 plus 5. Same happens for the next term. 302 plus 8 into 100C1 becomes 310 into 100C1. This goes on. Alright, notice that the sum will always be 310. Okay, even for the last term, it becomes 310 into 100C100. So this is nothing but 310 into what? 100C0 plus 100C1. Okay, this will be 2s. Alright, 2s equal to all the way up till 100C100. And we know that this is nothing but 2 per 100. This entire sum, 100C0 plus 100C1 up till 100C100 comes up to 2 per 100. What are we looking for? The value of s. So we'll divide the RHS by 2 here. So that becomes 310 into 2 per 99. And as you can see, from both the methods, I get the same answer, which is nothing but option D here. 310 into 2 per 99. Got that? Alright, this question is telling us that 1 plus x raised to n can be written as sigma x power r into AR. Alright, AR is a coefficient. Now, we need to find 1 plus a1 by a0 into 1 plus a2 by a1 all the way up till 1 plus an by an minus 1. So these are a product of terms. Okay, this here, right, what you see is nothing but a product of some terms. And here, the interesting part. Okay, 1 plus x raised to n, we already know is sigma r equal to 0 to n, ncr into x power r, right? So, this AR that we see here, don't mistake it for anything else. It's nothing but NCR. Alright, this AR, okay, is there to confuse you. Alright, and that we notice from the question itself. That is nothing but NCR. Alright, now let's begin. We have 1 plus x power n equal to such. Now here, I have to find 1 plus a0 by a1. Sorry, a1 by a0. 1 plus a2 by a1 and so on. Alright, so let's look at this ratio here. a1 by a0, a2 by a1, a3 by a2 and so on. Basically, AR by AR minus 1. And I already know that AR is nothing but NCR. Similarly, AR minus 1 will be NCR minus 1. That is what we divide with each other. Okay, from there we get NCR by NCR minus 1 equal to N minus R plus 1 by R. Alright, so this is what I used to get this. Okay, so from here, alright, I'll write this as N plus 1 by R minus 1. This R is there in the numerator, R is there in the denominator. I just take it outside. What are we trying to find out here? We are trying to find out 1 plus A1 by A0 into 1 plus A2 by A1 and so on up till 1 plus AN by AN minus 1. Alright, so this becomes pi, basically multiplying R equal to 1 to N. Alright, 1 plus AR by AR minus 1. Okay, now I found out that AR by AR minus 1 is N plus 1 by R minus 1. Alright, so this becomes pi R equal to 1 to N 1 plus, what is AR by AR minus 1? I already found that out. N plus 1 by R minus 1. Now you know why I wrote that minus 1 separately. Alright, so it cancels out with this plus 1. And then I get pi R equal to 1 to N, N plus 1 by R. Now N plus 1 is a constant part. Okay, if I take it outside the pi, how many times am I taking N plus 1 outside? I am taking N plus 1 outside N times because there are N terms here. R is moving from 1 to N. Alright, since R is moving from 1 to N, N plus 1 term in the numerator will be multiplied with itself N number of times. So I take N plus 1 power N outside. What am I left with? Pi R equal to 1 to N into 1 by R. Alright. Okay, not into 1 by R. Pi R equal to 1 to N 1 by r. Now this pi r equal to 1 to n 1 by r. What is that even? That is 1 by 1. Put different values of r. 1 by 2, 1 by 3, all the way up till 1 by n. So what do you get here? You get nothing but n plus 1 power n in the numerator and n factorial in the denominator. Okay, so this will be my final answer. N plus 1 power n divided by n factorial, which is nothing but option B here. Alright, got that? Alright, take a look at this question. It's given that n is a positive integer greater than 1. You have to find the sum of this given series here. Alright, so there are a bunch of terms here. Look from the second term onwards. It's NC1, A minus 1, NC2, A minus 2, up till NCN, which is 1, A minus N. Okay, note that the terms are alternating in sign. Okay, there's a minus in the second term, plus in the third term, and so on. Okay, now the first term here is simply A. I'll write it as NC0, A minus 0. Okay, which is the form in which the rest of the terms are written. Alright, so this can be written as sigma r equal to 0 to n. Alright, this becomes minus 1 power n, minus 1 power r into NCR A minus r. This A minus r I will use to split this into a difference of two terms, this product. Okay, so this can be written as this into A minus sigma r equal to 0 to n minus 1 power r NCR into r. Alright, now here A is a constant. I'll put it outside. And then what is remaining here? Sigma r equal to 0 to n minus 1 power r NCR. Okay, now here I can't take r constant outside because r is not a constant here, obviously. Now r into NCR, how do I take care of that? R into NCR is nothing but n into n minus 1 CR minus 1. Alright, we have this here. Let's use that. So then this r into NCR becomes n into n minus 1 CR minus 1. N is a constant here, which I'll take out of the sigma sign. R equal to 0 to n minus 1 power r into n minus 1 CR minus 1. The n here, I removed it outside. Okay, now I have this much with me. Expand this in your mind, please. NCR, when r goes from 0 to n. Okay, into minus 1 power r. So it will become NC0 minus NC1 plus NC2 all the way up till minus 1 power n NCN. Okay, this is nothing but the expansion of 1 minus 1 whole raised to n. Alright, got this? So basically, this here, this sigma part here, alright, becomes 0, the first one. The second one, let's look at it. Here you can see r is going from 0 to n. Does r go from 0 to n? No, it doesn't. R goes from 1 to n. Why is that the case? Because r minus 1 here in the subscript, you get n minus 1 CR minus 1. R cannot be 0. You get n minus 1 C minus 1. Not possible. Alright. So you take r values from 1 to n. And then let's begin. So here, what is this sum coming out to? Again, this becomes n minus 1 C0 plus n minus 1 C1. Sorry, it's not plus. It will be minus. Okay. So you see this minus 1 outside here and minus 1 power r. I'll let them interact. Okay. So it becomes minus 1 power r minus 1 into n minus 1 CR minus 1. Okay. Just to make the subscripts the same. R minus 1. Alright. Now I get n minus 1 C0. Okay. So here, okay, this bracket minus n minus 1 C1 plus n minus 1 C2 all the way up till minus 1 per n minus 1 C n minus 1 here. Alright. And this sum is also nothing but the expansion of 1 minus 1 per n minus 1, which is 0 per n minus 1, which is 0 itself. So basically, you are adding a into 0 plus n into 0. The whole thing has to come out to 0. Got that? All right. So let's look at our options. We are looking at nothing but option C here, which is 0. All right. All right. Take a look at this question. They're asking us to find K. If it's given that C0 plus C1 into C1 plus C2 all the way up till Cn minus 1 plus Cn is equal to K into C1 into C2 into C3 up till Cn. All right. So here I see that it's up till Cn. So I put Cn minus 1 into Cn. Okay. And that last Cn, I will write it as, what is NCn? I can write that as NC0. It's the same thing. All right. So I'll write NCn as NC0 and keep it there. All right. Now, what happens next? I'm looking for the value of K here. All right. K is C0 plus C1 into C1 plus C2 all the way up till Cn minus 1 plus Cn. Okay. I will take this NC0 and divide it for the first term here. Okay. So it becomes C0. I take this C1 and divide it for the second term here. And I take n minus 1, Cn minus 1 divided for the n minus 1th term here. Sorry, the nth term here. Okay. Just Cn minus 1 plus Cn. Okay. So this can be written as 1 plus C1 by C0, 1 plus C1 by C2, sorry, C2 by C1, all the way up till 1 plus Cn by Cn minus 1. All right. What is NC1 by NC0, NC2 by NC1, NCn by NCn minus 1? For that we use NCr by NCr minus 1, which is nothing but n minus r plus 1 divided by r. All right. So this can be written as product of 1 plus NCr by NCr minus 1, where r goes from 1 to n. All right. So here I will get this as pi r goes from 1 to n. 1 plus NCr by NCr minus 1 is nothing but n minus r plus 1 by r. Okay. This minus r divided by r becomes nothing but minus 1. Okay. And this cancels out here. Okay. So notice that I get this as n plus 1 by r minus r by r, which is 1. Okay. That's what I used here. All right. So then what am I multiplying? N plus 1 by r, and r is varying from 1 to n. So basically n plus 1 is multiplied by itself n number of times. So n plus 1 power n simply comes out. What am I left with? I'll just simply expand the terms there. 1 by r becomes 1, r becomes 2, r becomes 3, all the way up till n. Okay. So what will my answer be here? It's n plus 1 power n divided by n factorial. Got this? All right. So let's look at our options. We'll see that this is nothing but option A here. All right. That's the end of this question.